welcome to St. Mark's Lutheran Church. I'm Dr. Brian Salminen. I'm the pastor of St. Mark's. It's really nice to have you here as we begin our free lecture series here at St. Mark's that we hope and pray will be an outreach to not only our church, but certainly our community. We really have two goals in mind in our congregation. We want to be known as a caring congregation, providing services, care for people. We have Manna Monday, and all kinds of other ministries caring for people. But then we also want to be a thinking congregation. We want to engage cultural issues that are facing our world, our church, you and me as Christian people, and we want people to realize that the church has great resources to engage these topics. So, tonight it's my privilege to introduce our first speaker. I happen to know her well. If you like her, she listened to every word I taught her growing up. If you don't, she was always disobedient. But it's my privilege to introduce you kind of formally, and then I'll just share personally, Dr. Lauren Salminen. Dr. Salminen received her PhD in neuropsychology and behavioral neuroscience from the University of Missouri in St. Louis, Missouri. She completed a postdoctoral fellowship in neuroimaging and data science at USC in California, and currently serves on the research faculty at the USC Keck School of Medicine in Los Angeles. Dr. Salminen has authored over 30 publications and several book chapters on her research, which is funded by the National Institute of Health. She is very much interested in studying how demographic factors, mental health, lifestyle, and environment exposures interact to increase risk for Alzheimer's disease and related dementia. So our plan for this evening is that Lauren will lecture for about 45 minutes, maybe to an hour. We'll wrap up, and we're not going to keep you later than that, but then an opportunity for questions and answers. And then following, you're free to leave. We'll have some cookies and some drinks afterwards. But if you want to talk to Lauren afterwards, that'd be great too. So it's my great privilege and honor to introduce Dr., but also my oldest, my daughter, Lauren Salminen.
Thank you for that introduction. I'm really excited to be here today. This is my first in-person talk that I've given since COVID hit. So it's nice to not be in a Zoom chat room with all of you. I am really excited to talk to you guys today. I gave a similar talk to this a few years ago, and my research has changed a bit since then. Just as some context, a lot of my previous work focused on genetic risk factors for Alzheimer's disease and dementia, which I found interesting, but the problem is that you can't change your genetics. So it was a little bit depressing. So I kind of switched over into really understand factors that you can actually modify, and you can kind of be empowered to reduce your own personal risk for dementia and related syndromes. So I know the TVs are probably somewhat hard to, or the slides might be hard to see, so I'm gonna walk through each of the slides and hopefully it'll make sense. Okay, so just a quick outline of the things I'm going to talk about. So first I just want to go over some basic brain anatomy and discuss the lifespan changes in terms of brain structure and function to kind of set the stage for what optimal brain health or normal brain health should look like. Then kind of merge into what age-related cognitive decline is, what is normal aging, what is characteristic of typical aging, and then how does that transition into dementia and Alzheimer's disease? What is dementia? There are clinical characteristics that are very specific to Alzheimer's disease versus other types of dementias, and so I'll go through that. But I want to spend the most time talking about the established risk factors, and then really move into the role of the environment in terms of Alzheimer's disease risk, and then what the key modifiers are and what opportunities there are for intervention. Okay. So just some basic anatomy, and I don't want to get too dense here. So there are two types of basic tissues in the brain. There's gray matter and there's white matter. And these make up the neuron. So the gray matter is going to be the cell bodies, and I don't think the laser will work here, but so the green ball on the top of that middle picture, that's going to be the cell body, that's gray matter. And then the axon, which is that like long string-like thing hanging from the ball in the middle picture, that's going to be the white matter. So these two components of the brain have different functions. Those functions have sort of evolved over time with our increasing technology and our understanding of what these structures and these tissues actually do. A lot of my work has focused on the relevance of white matter because essentially a lot of earlier studies focused on how gray matter was really important for cognition, that it was the main tissue that was responsible for optimizing cognitive function. But a lot more recent work actually shows that it's white matter that may be more critical for maintaining optimal function. And part of that is because of the trajectory or how your gray matter and white matter changes over time. I might do next slide. Thank you. Okay, so this actually comes from work from my lab, and this was actually conducted in over 10,000 people. And each brain differently represents a different time point across the lifespan. So the brain on the farthest left, that's approximately age 7, and then age 15, and then following all the way across age 25, 35, 55, and 75. So you can see just by the colors, so red meaning growth, and blue meaning a decline or a decrease in tissue, that you have a pretty steady and significant growth, but really only up until like late teens, early 20s. And that's for the outer part of the brain, which is going to be the gray matter. After that, you sort of see the gray matter start to decline, and actually we found in our work that it's the gray matter tissue that actually begins to decline and stays declining after approximately age 20, which I also found alarming. But the good news is that white matter actually continues to develop well beyond that. So it's actually not until the point between age 35 and 55, it's about age 45, where you see white matter stop developing. So it's actually still developing until that point. And then after that, usually after about age 55, then you started to see subtle declines in white matter. But the inflection point, or the time in which you start to see white matter kind of make that transition from growth to decline, is when you also tend to see decline in cognitive symptoms, which is why we think that white matter is so critical for cognitive aging. Next slide. Okay. So this slide's a little bit hard to read, but basically it's just trying to show that unfortunately a lot of our cognitive functions decline over time. So this is definitely true for long-term memory, working memory, which is your ability to hold short-term information but also manipulate that information in real time. And those are part of the characteristic features of Alzheimer's disease. However, you do have an increase in world knowledge. So a lot of this is going to be cultural factors, just a lot of vocabulary, and this has been very consistently shown across several studies. And part of that increase in world knowledge has been believed to kind of compensate for a lot of the loss that you would see in working memory and long-term memory. So one thing that's interesting and very, I think it's one of the most important features of age-related cognitive decline is it's extremely variable between individuals. All three of us, or all of us in this room, could have completely different patterns of age-related cognitive decline, even in the absence of disease. So each point on these graphs here represent typical aging. So you can actually see how variable it is. So then the question becomes, what are the drivers of variability? Because we do know from a lot of the literature that the greater the variability, especially within the same person, so if you're tested over time on various different cognitive measures and you show significant variability on your performance, that is a significant risk factor for developing Alzheimer's disease later on. And this is just basically showing kind of what I mentioned earlier in terms of the curvilinear trajectory of white matter, which is circled in red, and how that begins to arc around age 50, which is likely related to the variability and the risk factor for Alzheimer's disease. So then if decline is normal, then what do we consider dementia? And so I think there's a lot of confusion in terms of what is dementia versus these specific syndromes. Dementia is really just an umbrella term for various different conditions that affect the brain, and specifically affected in a way that there is an impairment. So Alzheimer's disease is of course the most well-known dementia. It accounts for 60 to 80% of dementia cases. There's dementia, then there's Alzheimer's disease, and then there are these other different types of dementias. There's actually several more beyond the ones that are pictured here. But vascular dementia is the second most common. 10 to 40% of cases are vascular in origin. And what isn't pictured here, because we don't really know the number, is that most people with Alzheimer's disease also have significant vascular issues in the brain, which is what would be characteristic of vascular dementia. So for you to have a diagnosis of vascular dementia, you have to have significant vascular abnormalities. You likely will have heart disease. If you've had a heart attack, sorry. But hypertension, things like that, those are all risk factors for vascular dementia. There are also risk factors for Alzheimer's disease, so that's why a lot of researchers think that most cases of Alzheimer's disease and also vascular dementia is sort of a hybrid between the two. Next slide. So I just kind of wanted, since vascular dementia and Alzheimer's disease are the most common, I just wanted to briefly touch on what the different clinical features are. For vascular dementia in particular, you have a history of atherosclerosis and a lot of these typical cardiovascular factors that most physicians start checking, in your late 30s, early 40s, because that's when you unfortunately tend to start to see an increase in hypertension, blood pressure, and things like that. So for vascular dementia, the onset is very gradual. It's typically very gradual, but sometimes it can be sudden if it's precipitated by a stroke. That's a very common cause of dementia, especially if it's a severe stroke. Alzheimer's disease, however, is very gradual. Although we don't really know the cause of it, we have mapped out very, in a lot of different studies, the different stages of Alzheimer's disease, and it's pretty consistent across all of those studies. So Alzheimer's disease is slow progressive decline. And vascular dementia typically has a stepwise progression, which directly corresponds to the health of the vascular system. So there are a lot of things you can do to improve the vascular system, so diet, exercise, things like that. So when you improve your vascular system by doing things like that, you can kind of see a leveling off of impairment, which is why you have that kind of step. But then if you decline in your lifestyle and behavioral changes, then you would see a decline. Whereas Alzheimer's disease, based on what we know about the pathology, once that pathology is set in, you can't really do anything to get rid of the pathology. It's just there, unfortunately. And then the characteristic feature of Alzheimer's disease is going to be memory impairment. There are preceding stages to Alzheimer's disease called mild cognitive impairment. You have to have mild cognitive impairment before you get Alzheimer's disease. However, not all mild cognitive impairment progresses to Alzheimer's disease. So you could always stay in that stage. We don't really understand why at this point, but we do know that you have to have mild cognitive impairment, or it's called MCI, before you progress to Alzheimer's disease. And the hallmark feature of Alzheimer's disease is going to be impairment in episodic memory, meaning relational memory. So you might have a memory for things that happened a long time ago, but you have trouble forming new memories, and you really don't have capacity to remember things in the short term. By contrast, vascular dementia affects the frontal parts of the brain, which are extremely critical for decision-making, planning, being able to multitask. That's why a lot of people with vascular dementia actually, physicians will evaluate that to see if they're able to be safe drivers, because you have to make very quick decisions when you're driving your car in terms of when do I stop, when do I go. And vascular dementia, that system is hit really hard. So you tend to will have those privileges revoked, unfortunately, earlier if you have vascular dementia. We'll just do next slide.
Okay.
So I do want to focus on Alzheimer's disease, though, since it is the most common, and there's a lot of increased attention, and not just in funding institutes, but I've seen a lot of media attention surrounding it, because there's such a significant increase in cases. Part of that is because aging is the most significant risk factor for Alzheimer's disease. So the graph here shows the millions of people that actually have Alzheimer's disease, and it actually is a projection of how many people will have Alzheimer's disease by the year 2060, which is on the farthest end on the right. And you can see, and each of the colors represents a different age group. So the teal at the bottom is ages 65 to 74. The gold is ages 75 to 84. And then the purple is ages 85 and older. So you can see that increase is most significant with ages 85 and older. And part of that is just because of aging demographics of the world. The baby boomer generation, I believe the youngest of the baby boomers has already reached 65. Or they're going to reach it within the next few years. So that entire generation is going to be in this bracket. And so age 65 has sort of been identified as this somewhat arbitrary cutoff where you start to see decline. Arbitrary in the sense that it doesn't have a significant, when you turn 65, it's not like your brain falls apart. So don't worry. But we see in several studies that tends to be an age where we start to see decline. And if you have Alzheimer's disease or impairment earlier than 65, you'd be classified as an early onset case, which we think is likely driven by genetics. So if you have a family history, a lot of those cases tend to be early onset, which would occur prior to the age of 65. But otherwise, it's not typical to have, and those are much more infrequent. The age-related Alzheimer's disease is much more common. So just to characterize very generally what Alzheimer's disease is, it is basically a disease where there's plaques and tangles in the brain. So plaques are basically these amyloid proteins, and they're depicted in the image here in those like circle, like koosh ball looking things. And then there's the neural fibrillary tangles, which are the purple like kite looking things. And the tangles, actually, it's basically a twisted protein called tau. And what we know actually is that both of these things are characteristic of Alzheimer's disease when they occur together. And we've known that for a long time, but a lot of the recent research and technological advancements with brain imaging has really allowed us to see what these proteins actually look like in the brain. Maybe on the next slide. Well, actually, so there is an interesting divergence in terms of how tau, or the tangles, maps onto cognitive decline versus how amyloid, which is the plaques, maps onto amyloid. I don't know if anyone has paid attention to the news recently, but they recently approved an Alzheimer's disease a drug, which has been very controversial in my circles, and because that trial was largely based on getting rid of or clearing amyloid. Unfortunately, amyloid is not closely related to cognition. That's tau. So, and the studies are very clear on this, and actually the studies from Biogen, which is the company that was running the clinical trial, they have not shown any success between that drug at this point and having an impact on cognitive function. So that's part of the controversy why there's been so much pushback, especially from clinicians. And full disclosure, I'm not a clinician, so if there is one in the room, feel free to jump in. But from the clinicians that I work with, they've had several of their patients come to them saying, oh, I want this new drug because it's been all over the news and this is something that can help me. But unfortunately, the data actually don't show any improvement, at least yet, in cognitive function. And that's because it targets amyloid, which is not very related to cognitive function, according to all the studies that exist so far. Tau is, and when you have tau and amyloid together, that is when you start to see this correspondence. And so the images here show several different cognitive tasks. The ones that would be really significant for Alzheimer's disease would be delayed recall of like a short story. And that's in the middle graph on the right. And then you also, anything that's delayed, so delayed list recall, delayed short memory recall, because it requires you to retain the information. So usually when the testing occurs, you have to hold that information in your mind for at least 30 minutes. So when you can't repeat back certain elements of the story, or you can't repeat back those words that you learned in the list learning phase, then that becomes a significant issue and is a red flag that you might have Alzheimer's pathology. Next slide. So this is a really complicated slide, but I think it's important to just show and just to kind of get the general sense that there are very clear and distinct stages of Alzheimer's disease. And what's really important is that Alzheimer's disease pathology begins decades prior to the onset of clinical symptoms. Which is part of the reason why a lot of researchers have argued that the clinical trials focus on trying to find a cure or even just an intervention that could reverse or prevent further cognitive decline for Alzheimer's disease patients is because so much pathology has already occurred and that you can't, but at that point it's too late. So a lot of people have argued that these clinical trials actually need to be started in 20-year-olds and 30-year-olds because that's actually when the pathology begins. So the different curves here basically represent the different methods in which Alzheimer's disease is currently assessed. So they have newer imaging techniques that can actually measure amyloid. They also have different techniques, which is that's that first red curve. The orange curve actually measures the metabolism in the brain, and that has shown to be a really, does have good correspondence to cognitive function as well. So Alzheimer's disease, there's a decrease in metabolic function in the brain. And then the green line, or the green curve is tau. And there is tau-specific imaging as well now. That's very new technology. The blue line is MRI, and that's when you would actually see, if you have an MRI scan, that you actually see a shrinkage of different structures. And then finally we get to cognition, which is the purple line. So you can actually see changes in these different biomarkers significantly before you ever see a change in cognitive function. You might actually see, it depends on the study because this is a little bit variable, but we also think that, at least from animal studies, that there is microbiological changes happening before you can ever see an effect in amyloid. So that kind of brings us to, okay, then what do we do next? Next slide. This is just to give you a sense of what a normal versus abnormal brain looks like using these different imaging techniques. So amyloid, these are all positron emission tomography is PET. That's a specific imaging technique that's used to measure these different biomarkers. So in the first column, you're looking at amyloid. The top row is a normal brain, the bottom row is an abnormal brain. So basically, anything that has an increase in red is basically showing an increase of that specific protein, or in the case of metabolism on the far right column, is basically showing a decrease in metabolism. But basically, you can see in the first column that there's significant red compared to the normal brain all over. So amyloid is very non-specific. It just affects the whole brain, which is why we think that it doesn't really map onto cognition because it's not specific. Tau is very specific. So that's the middle column. And if you can see, you can't really see much at all in the normal brain. It looks pretty clean. In the bottom image, we see that it actually affects the temporal lobes, which is where we know that Alzheimer's disease pathology begins. And that's also why we think that tau strongly corresponds to a decrease in memory capacity and memory retention. Next slide. So the diagnosis of Alzheimer's disease is complicated, and to be honest, it is evolving at the most rapid speed. Within the last year, I've had discussions with people that do not have an agreed upon way to diagnose Alzheimer's disease. It does require a thorough medical history, neuropsychological evaluation, and brain imaging. And that has been typical for a long time. But the question is then, what do you do with that information? So next slide. So one of the current recommendations, and this is from the NIH, is this ATN criteria, which is essentially A for amyloid, T for tau, and N for neurodegeneration, which really just means, do you see a shrinkage in structures on an MRI scan? But there are all these variations of what would indicate Alzheimer's disease, and that's depicted in the blue on this image. And part of the controversy is that certain scientists believe that you can have Alzheimer's disease if you have amyloid, tau, and neurodegeneration, but you're totally cognitively normal. And that you can actually have all of those things and be totally cognitively normal. So a lot of people actually don't think, well, while we're all walking around fine, like, do I have Alzheimer's disease? It doesn't really make sense in terms of like the purpose of having a diagnosis is so that you can treat it appropriately. But if we know we can't reverse the specific biomarkers in the brain, and if the cognitive function is normal, there's nothing to treat. So that's kind of a controversy right now, but that is where the field is going, is to have a specific and biological definition of Alzheimer's disease. The alternative is that people also want to keep this criteria, but say you may get Alzheimer's disease because you have these three strong risk factors, but you don't have it if you're cognitively normal, which is probably where that will end up. Next slide. So just to go over the established risk factors, I mentioned before age. The image here, you can see a strong increase in terms of Alzheimer's disease prevalence by age. It's a dramatic increase from 3% to 19% between 65 and 75. And then over 85, almost 50% of people have Alzheimer's disease. Next slide. Family history, again, I mentioned, is it's a small percentage of the cases. I do want to highlight ApoE4, which is the late onset, so after age 65. Next slide. If you have this specific genetic variant, you have a significant increased risk for Alzheimer's disease. And there's been a lot of advances in genetics in the past decade or so, and a lot of those efforts have been to try and find additional genetic markers, because even though this is a significant risk factor, it does not at all predict your likelihood of it's a risk factor. It is not, if I have this specific variant, it does not mean I will get Alzheimer's disease. There are different variants that you can have, and so the ApoE4, which is the tallest column on the far right, is the significant risk factor for Alzheimer's disease. Most people have ApoE3, which is the second bar to the left. You can see that's you have a low risk. You can have, for this specific gene, there's two variants. Everyone has two copies. So you can have any combination of these specific variants. Most people have 3-3, as in 75% of this room probably has a 3-3. If you have at least one E4, then your risk goes up significantly. And you can see that based on that increase in the bar. If you have two E4s, it's a dramatic increase, and that's the bar on the far right. Next slide. And we think this might actually explain some of the variation in terms of risk factor by race. Individuals who are Black and Hispanic have a significantly higher risk for Alzheimer's disease than white. And partly we think that's because there is a significant difference in genetic makeup in terms of the prevalence of ApoE. So the red bars here show that Black or African Americans, the prevalence of having one E4 is about 29% versus 21% in white. And then if you have two of them, it's 4.5% versus 2.4%. So it's a significant difference. And we think that might be contributing, not entirely, but it might be a main contributor of that. Next slide. Females are at much higher risk. You can see these are even at different ages, at 45 and age 65, they're still at higher risk. Almost 2/3 of Americans with Alzheimer's disease are females. Next slide. And this is just to show that there are a lot of specific biological factors that have been proposed to account for this, but what I want to highlight at the end is that increased longevity. Women live longer than men. And if age is your biggest risk factor for Alzheimer's disease, and we know that it is, then part of that increased risk is that you live longer. Next slide. But I do just want to highlight here that even though, unfortunately, females are at higher risk for a lot of conditions, but there is a difference in terms of just looking at different neurodegenerative disorders. And this figure here just kind of gives you an idea. If you look at the green versus the blue, the green is female, the blue is male. So Parkinson's disease, which is the top one, that's more common in males. Multiple sclerosis is much more common in females at 72% versus 28%. And then Alzheimer's disease right after that, 68% versus 32%. And then you see vascular dementia, which is actually somewhat surprising since men have so many more vascular risk factors. However, they also die earlier from them. So women live longer, but with dementia. So good news, I guess. I don't know. However you want to take that. And then two very rare forms below. Next slide. Okay, so I think this is kind of where a lot of my work was on the genetics of Alzheimer's disease, and I've done work on APOE before. But again, at least at this point in science, we can't change our genetics. And we can't change sex, race, all those things. So what can we do to mitigate our risk? And are there other sources? Next slide. So the current motivation for my work is actually trying to figure out what those sources are. Next slide. And especially to understand things that can guide immediate intervention, even if not on a clinical trial scale, are there things I can do in my life right now to lower my personal risk? So psychosocial stress is one major factor. It's a major exposure, and this could include anything from childhood adversity, health problems, sustained family conflict, combat, grief, financial strain. All of those are psychosocial stressors. Next slide. There's also toxicological stressors, and that includes anything from secondhand smoke, exposure to pesticides, air pollution, water contamination, and occupational hazards. These things tend to co-occur. So if you have higher psychosocial stressors, you also probably are exposed to higher levels of air pollution, water contamination. Part of that is because they tend to disproportionately affect those of individuals with lower socioeconomic status, people with lower income households. So there's a huge disparity in terms of wealth and exposures. And I don't think that's new information, but I think people don't necessarily recognize or realize that these are strongly positively associated. And that's really just because stress brings more stress. Next slide. So a lot of what my work has tried to explore and understand is how do these factors interact? And especially how do they interact to influence brain aging? How do they influence an accelerated pattern of brain aging? And then how does that subsequently affect Alzheimer's disease risk. And then what are those mechanisms that contribute to that? Next slide. This diagram here just kind of shows the way that neuroscience thinks of a lot of different conditions, including Alzheimer's disease. The current model is it's a biopsychosocial model, meaning that there's a lot of different interactions that affect your risk for Alzheimer's disease and other syndromes as well. It's biology, it's psychology, it's sociology. And this is pretty accepted. Next slide. Most studies focus on biology. And next slide. But largely ignore the environment and the context in which all of these factors are occurring. And partly I think that's because we're always in our environment. There's no scenario where we're removed from it. So even though we know that there are strong biopsychosocial interactions that influence risk, we also don't consider, next slide, that these specific environmental factors, which I have here, pollution, prenatal nutrition, secondhand smoke, occupational hazards, childhood trauma, household pollution, they're all linked to significant mental health, physical health, and neurological health conditions. Anything, it's probably hard to see on screen, but these include Alzheimer's disease, but also several different psychiatric disorders, major depression, PTSD, autism, things like that. Next slide. So this ultimately results in a shortened lifespan. Next slide. And a shortened health span, which is the one thing that we want to improve. So it's not really any good if we are extending lifespan, but more of that time is spent disabled. We want to extend the healthy lifespan. And there's quite a gap right now between a healthy lifespan and lifespan. Next slide. So I wanted to highlight here, this comes from the Global Burden of Disease study, and this actually shows the the top 20 risk factors for all-cause death on the left, and then all-cause disability on the right. The first column is global, worldwide. Second column is in the US. Third column is Wisconsin. So I sorted it according to Wisconsin, and what I wanted to highlight in the red is that on the graph on the left, occupational asbestos is number 14, and then number 16 is exposure to ambient particulate matter, which is air pollution. On the right, you actually see bullying is number 16, followed by ambient particulate matter, then also intimate partner violence and childhood sexual abuse. Those are among the leading risk factors for all-cause disability in Wisconsin, unfortunately. Next slide. So what I really want to focus on is air pollution, and I'll tell you that part of the reason I got into this is because I moved to Los Angeles. And it was very apparent that it was quite a different environment from where I was in St. Louis, Missouri, just in terms of the smog. I think when people think of pollution, they think, oh yeah, well, asthma or something. That's true, but it's also a leading cause of death and disability worldwide. I want to highlight the graph on the right, the top 20 global causes of death in 2020. This comes from, this was published in May of 2020 last year. It's the fourth leading cause of death. COVID-19 is the red bar several down. It's more than diabetes, it's more than pneumonia, alcohol, tuberculosis, hepatitis, tobacco, by a lot. And then if you look at the pie charts in the bottom, you see the percent of global deaths from specific causes. So the far left is COPD, towards the right you have stroke. Air pollution accounts for 40% of COPD, 30% of strokes. Next slide. So I just want to clarify what I'm talking about when I say air pollution. In 1990, the Clean Air Act made the U.S. responsible for monitoring and regulating different air pollutants. These are the pollutants they focused on. It's lead, nitrogen dioxide, ground level ozone, sulfur dioxide, carbon monoxide, and particulate matter, which is what I want to highlight because that's what most studies focus on. And essentially, it just refers to microscopic solids and liquids that are suspended in the atmosphere. They could be of any chemical composition, but they're measured based on their size. And so fine particulate matter, which is referred to as PM2.5, which is literally just the size of the particle, has been shown to be the most damaging for health because when you inhale it, it actually can go to anywhere in the body. It can pass through these biological barriers because it's so small. Next slide. And this is just a really complicated slide to show you that there's 2 ways that it can get to the brain. One is through the nose, literally goes right into your brain. And then the other is through inhaling it through the mouth. It can go deep into your lungs, get into the bloodstream, and ultimately access your brain that way. Next slide. This is just to show you what the air quality guidelines are. I know it's really hard to see, but good is basically a level, we're talking about PM2.5, 0 to 50, that's in the US. The World Health Organization is much more strict in terms of what qualifies as good. They say 10, it's quite a difference. But we know that there's actually no acceptable or good level of pollution. Next slide. It disproportionately affects the young and the old. Essentially this just shows you by age how air pollution actually contributes to numbers of deaths. So those are disproportionately on the end of older adults. Next slide. A lot of studies have investigated how it contributes to dementia and cognitive decline. PM2.5 has the strongest evidence so far. This is also a much newer area of research as well, so there hasn't been a ton of studies, but of those that exist, it's that PM2.5 that is a significant risk factor for dementia and cognitive decline. Next slide. This study is just to show that there's a specific study that's conducted in women. It's the Women Health and Memory Study. And if you have that genetic variant, that ApoE4, your odds of having dementia are 264% higher if you live in an area of high PM2.5. That's quite significant. And actually, if you just look at everyone altogether, independent of genetic risk, if you live in an area of high PM2.5, your increased risk is 81%, independent of that genetic risk factor. Next slide. And this is just to show that actually there have been several studies that have been conducted in Mexico City, which is heavily polluted. And this researcher has several studies showing that you actually can identify Alzheimer's disease pathology in children and adolescents. And it directly corresponds, it's a strong positive correlation to the levels of air pollution in that area. And this actually comes from, so it's information that's found in autopsy. These are all people that died of factors that did not affect the brain. Most of them were car accidents or something like that. But what you can see is that they actually did have information about prior to death about cognitive function. And this is, again, less than or equal to 30 years old. They could identify, based on cognitive performance, a significant proportion with mild cognitive impairment and Alzheimer's disease, just defined by those typical cognitive thresholds in young adults. Next slide. And this is just another example. This is from the same research group, just showing that increased risk according to PM2.5 and those tau tangles. Next slide. There's not a lot of imaging that has been done, and I can't say that at all. So, but this is all of the imaging studies that have been done in older adults and air pollution. This is everything. That's not a lot at all. And what's especially noteworthy is that only 5 countries are represented, and we know that the air pollution varies dramatically across countries. And all of the words you can see on the far right are the different factors that people adjust for. So if you have alcohol use disorder, if you have diabetes, you have all these other things, which we know matter a lot. So we don't really quite understand how these pollutants actually affect the brain. Next slide. So I do want to highlight, and I'm short on time, but the key modifiers of air pollution exposure effects. So there are things that obviously that we can't change, and that's still going to be age, sex, ApoE status. Those actually do show strong modifier impacts in terms of what the outcome is on the brain. But there are things that we actually can modify, and smoking and exposure to smoke, health history, this is arguably modifiable depending on what you're talking about, and then mental distress physical activity and nutrition. There are a lot of other factors also that within the environment that interact with each other. So things that I think that are very recently people are becoming aware of is that green space, how much green space you have access to, is actually a significant protective factor against Alzheimer's disease. There's a lot of research showing the benefit of nature. Researchers aren't really sure if that's because it's actually related to oxygen consumption or whether it's actually just some other hidden variable that we don't quite understand yet. There's actually evidence to show that spirituality, and increased spirituality is strongly positively associated with access to green space. And the opposite is true if you're in very urban environments. And so we're trying to really understand how those factors interact. So if you live in New York City versus the Amazon, I guess, what is the relative impact that that's going to have on the brain, especially when you're considering all of these other environmental factors. Next slide. Next slide. So I did want to emphasize that environmental tobacco smoke is a major contributor to air pollution. And this study came out actually showing that air quality is worse in a pedestrian area that's frequented by smokers than when you're in a high traffic area. And the graphs here actually just show the difference, and time is on the bottom axis, and the number of smokers is depicted on the right, and the smokers is the really faint dashed line, and especially during recreational hours when people are out, which is what those two columns in the graphs represent, you see a significant increase in spike in terms of air pollution that's attributed to smoke. And that smoke can travel very long distances. Because it's that fine particulate matter, it doesn't have any weight to it, so it can just stay in the atmosphere. Next slide. You can keep clicking it, because there's a lot of, yeah, okay. Actually, go back one. So this is just to show that this image actually shows that all the toxins that go into secondhand smoke. The images are supposed to show all the different chemicals: benzene, formaldehyde, chromium, if anyone saw Aaron Brockovich, that's in it. Lead, which we all know is a neurotoxin, based on what came out of Flint, Michigan. But all of these different elements, they're all part of cigarette smoke. And we actually found in a recent study, next slide please, that you can see the effects of exposure to smoking around the time that you're born, decades after you're exposed. So this study was conducted in older adults between the ages of 50 and 75. And what we saw is that if you just simply said that you were exposed to smoking around the time that you were born, that you had this significant decrease in specific areas of the brain. Next slide. I'm almost done. Okay. Next slide. And then, so mental distress is one that's particularly interested in. It's what a lot of the work that we're specifically focused on now. We just submitted a grant on this, so hopefully it gets funded. So if we think about that psychosocial stressors and toxicological stressors, they tend to co-occur. If I'm exposed to high psychosocial stress, I likely have a lot more toxins around me. But they actually also converge on the same biological pathways in the body. They actually have the same mechanistic harm. So that means that not only do, if I'm exposed to more things, then it's just an increased load that I'm carrying in terms of toxic exposure and psychosocial stress, but that's actually having a compound effect internally because they're affecting the exact same systems. Next slide. This is a little out of order, but this is just to show the global distribution of PM2.5, and I mentioned before that this specific pollutant is just a chemical mixture. A lot more recent work has been able to parse out what goes into that mixture. These are the 7 main components of that mixture, so dust, black carbon, ammonium, sea salt, organic matter, nitrate. And you can see this is just a global map. There's significant variations. You can see there's a lot more dust in Africa, which is not really surprising. But the US has a lot more sulfate and ammonia. So part of the reason we think that we see a lot of variability in terms of previous air pollution studies is because even though they're measuring the same size particle, what that particle actually is actually very different across studies. Next slide. Next slide. So ultimately what we want to do is try to understand what the interactions are between the external environment, smoking, any source of toxins, and that's a specific external environment. The general external environment, which is really anything we're exposed to on the freeway, anything in our environment. How does that then influence the internal environment to impact individual health risk and assessment? Next slide. Next slide. So the one thing that we can do now is actually be really vigilant. I know a lot of people find this somewhat depressing, but I actually find it really empowering because knowledge is power. So because you can actually do something about environmental factors, then you can do something about environmental factors. So limiting your personal exposure. So I think knowing what those personal exposures are then allows you to address them. In the indoor environment, we actually spend like 90% of our time indoors. However, the outdoor environment does seep in through various sources, and they're sort of depicted here in terms of just opening doors, opening windows, just general infiltration. But there are air purification systems that are outstanding. You can significantly, I got one at Dyson, I highly recommend it. I'm not a spokesperson for them, I just really like their product because you can actually see in real time, if you light a candle, the air quality, it's a single candle in a separate room. Within about 10 minutes, you can see the air quality go from good in the green to red in the danger zone, just from one candle. And I have a big candle lover. I used to have candles all the time, but that's one major source of pollution in the home. Next slide, I think I talked a little more about the sources. So the main sources of indoor air pollution are cleaning products, air fresheners, unfortunately, perfume, carpet, central heating, and candles. Cleaning products in particular, those are not regulated. And you probably tell now in a lot of stores that they'll have like a clean label on it with like a green check mark. I would pay attention to those. I would also pay attention to anything that says the word fragrance in it. Anything that says fragrance could be literally anything. It's protected under, I can't remember the specific act, but it's protected for companies that they can include any single chemical they want if it's labeled fragrance. And there have been studies to show that there are significant carcinogens in a lot of those products. And I also tell you, if I spray air freshener just like one time, my Dyson like goes way up. Perfume again, but there are a lot of non-toxic alternatives at this point. There's certain stores that literally are completely branded by non-toxic, healthy, and fully disclosed ingredient lists. Next slide. Okay, so just limit these things. I think there's a time and a place, and of course, these are all things that everyone likes, and so part of it is maybe a slow process, but just even being aware of it, I think is powerful. Next slide. Okay, yeah, that's it. So anyways, I just wanted to thank you for listening to me, and hopefully you learned something, and I'm excited to answer any questions.
We now bring our offerings to the Lord. Just kidding. Thank you very much, Lauren. Sure appreciate it. Time for question and answers. We have a microphone, but anybody have any questions for Lauren?
Hey, Lauren, how do you determine air population in cause of death? Is it only through autopsy?
No, there's actually, that's a good question. Like from those risk charts. Yeah, so that global burden of disease study is a huge team of researchers that actually annually reevaluate this, reevaluate different risk factors. It's actually an interactive tool that anybody can go to. It's called GBD Compare, and you can actually do different filters. That's how I got Wisconsin. And you can actually see by year. You can make it really specific or really general to see not just causes, but risk factors. And ultimately, the team that come up with this, they're very advanced biostatisticians that I could not tell you the algorithm, but I trust them.
Just one more question. On the weather we see, oftentimes there's air quality warning.
Mhm.
And is that measuring that PM?
Yes.
Okay.
That is the primary. I think there are some systems that will include other pollutants as well, but it's usually PM2.5 because it is universally recognized as the biggest health risk.
Thank you.
Mhm.
Question back there? Yes.
You said, quote, you can't overcome your genetics, end quote. But then there's always this feeling that if you have lived a different lifestyle than maybe others, maybe you can put off the genetics that
Mhm.
other family members may have been succumbed to, let's put it that way. So is that true?
Yeah, so genetics, I mean, the field is so complicated, but most genetics are not deterministic. There are some, but in general, and especially for Alzheimer's disease, it's not, again, there are people that have that risk variant, ApoE4, that don't get Alzheimer's disease. So it's not deterministic, it's just an increased risk, which is why, to your point, being aware of these other things that interact with that gene, which is air pollution, and I didn't get fully into that, but that women's health and memory study that I mentioned, significant interactions between that gene and various brain regions, that gene and air pollution on the specific brain regions that are affected the earliest in Alzheimer's disease. So if you can minimize then like your exposure to pollution, then theoretically then you can reduce that risk that would already be offered to you by that genetic risk factor. So yeah, but then there's a lot of different other behavioral and lifestyle factors that could also mitigate that risk or lower it.
Somebody else had their hand up? Yes.
Yeah, I did. So they talk a lot about like the microbiome
Mm-hmm.
related to health. And so I'm curious what your thoughts are on that, the microbiome related to Alzheimer's, and do you see a connection there?
For sure. It's really complicated. I definitely think that that's where the field is going. It's so complex that I think it's going there really slowly because a lot of the new advances in science require really specialized training. Almost the new technologies require, even for people that have had medical degrees or have been experienced researchers for decades, these new tools that can measure the microbiome and other parts of biology really require almost like an entirely different degree. So I think it's just moving slowly, but we do know that things like dental health is a significant risk factor for Alzheimer's disease, like much more than I actually realized. So that's part of the reason why they, if you go to the dentist, they usually, well, I guess depends on age, but sometimes they will actually ask for, if you, depending on your age, if you're over age 50 or 60, they might ask if you've had any issues with cognition or something like that. Because if you've had cavities, any bacteria, it can get directly into the brain. There's a lot of other microbiome components, I think, that are really interesting.
Just to add to that, so have you heard about Dr. Bones? I think it's in this, where he's really more of the nutrition related to Alzheimer's, and is that, would you say that also is a factor as far as sugar? He talks a lot about getting all the sugar out and really healing the gut.
Mm-hmm. So I'm not familiar with that specific doctor, but I absolutely think that nutrition matters, and that's actually one factor that I could go on for days, but one thing that our lab is actually trying to focus on is actually, can you reduce some of the risk from pollution actually by modifying your antioxidant intake? Because we actually know that vitamin C is a strong combatant to smoke and a lot of those related toxins. And that is also partly why we think there are certain populations in the world that actually have heavy smoke consumption, but they have Mediterranean diets and significant consumption of vitamin C, and so they have very low incidence of lung cancer, even though like they have an extremely high rate of smoking. So those are things that we're looking into, but I absolutely think that, I mean, nutrition is one of those things that I think we don't know we need to have good nutrition. What good nutrition actually is not always as clear, because I think it's also evolving too, and there's so many new diets out there, you know. But sugar is for sure, I think the literature is also pretty clear that, you know, an excess in sugar it's not to your benefit.
There was a question over here, gentleman over here.
I don't need the mic. I don't need the mic. It's not on anyway. You go to speed of light, so I didn't have time to write.
Oh, I'm sorry.
So I'll go, one point at the beginning, middle, and end. In the clinical comparison chart at the beginning, you have between vascular and Alzheimer's.
Mm-hmm.
The one section you have is GAIT, G-A-I-T.
Mm-hmm.
How do you describe that as far as how you use it with vascular and Alzheimer's, the GAIT?
Yeah, so that's a term related to movement. Like Parkinson's disease is characterized by a shuffling gait, which is kind of like walking like this and not picking up your feet. I'm not a clinician, and I'm also not a specialist in Parkinson's disease, but typically you have more issues with movement and gait in vascular dementia than you do with Alzheimer's disease because of the structures of the brain that it affects. Vascular dementia tends to affect the regions that affect, motor movement, gait, even fine motor movement, which is, like using your pen or things like that. Whereas Alzheimer's disease is much more, the location of it is back here, which is not as much, not really where motor is, movement is generated.
So it can be pretty varied, the individual doesn't have to do this,
Oh no, there's a lot of different, that's an entire field, yeah.
Let's go to the middle part. At what point do you make a decision to do brain image scanning?
You mean if somebody you think somebody might have Alzheimer's disease?
Yeah, at what point do you decide that you're going to go to brain imaging? What makes the decision?
That's a really good question. It wouldn't be the first thing that you would do. It would typically be after you've already had an initial evaluation by a clinician, usually multiple evaluations, an extensive cognitive testing session. It's usually that cognitive evaluation that will determine if you need a further evaluation with brain imaging.
There isn't a cut and dry point where you say, we'll have to use brain imaging.
Not in terms of, only so much that the cognitive exam indicates it. So if you have if you perform extremely low on tests that are, indicators of Alzheimer's disease, then that would be an indicator that we need to do brain imaging now. But other than that, no, there's no time scale that we would say this is the time that we need to do this.
All right, since I don't want to take up more time, but let's go to the end where you talk about candles. I just want to make a plug. Don't use candles in your home. Just use beeswax if you use it. Everything else will give you all kinds of weird symptoms. But don't use candles in your home.
I agree.
Okay, thank you.
What do you think of the test for MOCA?
The MOCA?
Yeah.
Yeah. That's a good question, especially because it was on the news a lot related to, I think Trump took it or something like that. It's a screening tool. So it's not, when you get actually evaluated for cognitive performance, you're typically not getting the MOCA. I know that's what happened with Trump. But if you're genuinely getting a test because there's a concern that you might have an impairment, you would never get the MOCA. Because it's a very short, it's literally a one-page document that it covers several different elements of cognitive function. So your speech, your decision-making, and memory retention. But each of those domains, there's like 3 questions about it. It's not sensitive at all. So it's used in research because a lot of times it's what is accessible, and especially for studies, one of the main issues when you're recruiting participants, and especially if it's a cohort that has risk for Alzheimer's disease and might already have cognitive decline, is there's only so much time that person can be assessed for. They're not actually ever going to come back. And before it becomes also, almost inhumane in terms of we're not going to make someone sit there for 4 hours and do test after test. So ultimately, I would say it can be informative for preliminary evidence, but other than that, that's it, I think.
I'm an administrative specialist for your Jefferson County, and what we use is a mini pad, just for a conversation tool. So if we're doing it, we see some type of impairment or a baseline, we're going to send it over to the doctor so they can either keep it on file or that they can have it for that further conversation as well. But then we hope that they would do further.
Right, exactly. Yeah, no, actually, I'm glad you said that's a perfect example of why that would be relevant. Is there does need to be a process of screening, and that is why it's a screening tool. Like it is an effective screening tool, but then, like you said, there must be further testing to actually see what is going on.
Good question over here.
What kind of relationship does your researchers have with medical professionals? Because the experience that I've had, there were some tests that my neurologist had wanted to have, and they didn't want to give them until the postmortem. That's never going to help a whole lot. There was like 5 years difference from the beginning until the second test, and we had to fight insurance hours to get people to fight for getting a test. And with the medical and insurance that people have, it's not easy unless you can get into some research program that maybe they won't charge you for the test. But I have a real problem with research telling you all of this stuff, and yes, you can see this or that, but in the real life activities, when you're going to doctors and doctor after doctor and trying to figure out what tests you need, what cognitive tests. My husband went through hours of tests, like you were just saying, hours of tests, 4 hours at a time, multiple times, over a period of 7 years before dementia took him. But the insurance issues, the medical issues, and the research issues, what do you do to help that?
It's a really great question, and I'm not a clinician, but we work really closely within our team. We have our direct team has physicians, some that are just research physicians, some that are physician clinicians, so they're doing research and they're seeing patients. Those actually, I like to meet with those the most because for situations like that, they actually have the real world of who's coming to the clinic and actually what are they asking for and what do you see versus like what do we think, or just going off of the literature and the research that exists. The problem that I think that we've seen is that a lot of physicians aren't research physicians; they're physicians, and that's their job, and that's great. But because research is evolving so fast, there's no way that you can possibly keep up with all of the latest research, especially if your job is not to be a researcher. It's honestly really hard to keep up with as a researcher. So, it's just a really fast-moving field, and I think part of it's an ongoing debate in terms of, I think I've heard a lot of clinicians or physicians, say that, it's really annoying when patients will come in with information that they research, but I think a lot of people do know how to research. Maybe if it's a Wikipedia evidence that they'll probably throw that away, but if it's if it's a legitimate study, I think a lot of physicians just haven't seen it, to be honest. In those cases, unfortunately, I think you kind of need an advocate that has some connection to the medical space. I wish that was not how it was, and I'm hoping that will change in the future, but just from what I've seen, I'm not surprised. It's really sad, the scenario you described, but I've heard that a lot. So I think just having somebody that you can connect with that can maybe bridge that gap is unfortunately right now the best option.
We have one last question. Okay.
guess yes, but I don't know all of the, the logistics, but,
Can you surmise the question? We couldn't hear it back there.
oh, sorry,
I don't know what your answer.
yeah, so, what is the specific, it's a farm?
Yeah, it's a large farm, they call it farms.
Okay.
They have lots of farms. Not just a farm, I grew up on a farm. But then it was just put out in the field.
The manure, okay.
Yeah, now they have the pit, they call them pits. And if you, the so the biggest usually from the west, so they bring it out of pumping out of the field somewhere, and
Yeah, so she's saying that she's on a farm and there are these manure pits that have a really strong stench that's distinct from manure. Is it possible that there's something, some chemical, I guess, that's being released that could be affecting, whatever biology? Do you know if there's any specific chemicals that also are in those pits?
methane,
Methane?
I don't think it's.
Or I don't know where that came from. Did I get that right? Methane?
Yes.
Okay, then I would say yes. Honestly, if you can smell it, I would then I think they'll sometimes think like, oh, we're just smelling it. Smell is something. Like even if we can't see the particle, like there's still something that's activating that smell. And interestingly, and I didn't mention this, but smell is loss of smell is one of an early sign of Alzheimer's disease and other dementias. So it kind of follows that same route of chemical exposure. It's also why the pesticide exposure was initially linked to some of those dementia syndromes.
Let's thank Lauren. If you did not sign in, we would appreciate it if you would, because we want to be able to send out information on our next speakers. We have a person coming in September, Reverend Dr. Greg Seltz, who is the Executive Director of the Lutheran Center for Religious Liberty, and he works specifically in Washington, D.C. regarding what does it mean to be a Christian and relating to government and all the changes that are taking place. So if you would, please just give us your name and our email or address so we can keep you apprised of all of our next speakers, okay? Thank you so very, very much for coming in. There's some goodies behind in the back of the church, some water, and if there's a bunch of stuff, Lauren, please feel free to do so. Thank you very much, and God's blessing.